Hello and welcome to G Fun Facts Online. Imagine looking deep into space and seeing something completely new. Not a star, not a galaxy, but a faint ghostly ring of light, so vast it could swallow our entire Milky Way hundreds of times over. In 2019, astronomers found exactly that. They call them odd radio circles, or ORCs, and they are one of the biggest mysteries in modern astronomy. These cosmic enigmas aren't visible to the naked eye, or even to powerful optical telescopes like Hubble. They only glow faintly in radio waves. Their discovery was a complete surprise, found almost by accident. In late 2019, astronomer Dr. Anna Kapinska was sifting through mountains of data from Australia's new ASKAP radio telescope. Amidst the familiar dots and smudges of distant galaxies, something stood out: faint, perfectly circular shapes. The team, led by Professor Ray Norris, was initially skeptical. In radio astronomy, strange circles can often be glitches in the equipment or errors in data processing, ghosts in the machine. But after cross-checking with other telescopes, they confirmed the circles were real. They were out there, and they were very, very odd. The name stuck. The first scientific paper introduced 4 of them, simply named ORC1 through ORC4, and kicked off a global detective story to figure out what they are. Unraveling this mystery requires a team of powerful telescopes, each with a special skill. The discovery was made by ASKAP, the Australian Square Kilometre Array Pathfinder. Think of ASKAP as a wide-angle lens for the radio universe. Its massive field of view allows it to scan huge patches of the sky quickly, making it the perfect tool for finding rare, faint objects like ORCs. It's the discovery engine. But once you find an ORC, you need to zoom in. That's where Meerkat comes in. Located in South Africa, Meerkat is like a high-resolution magnifying glass. It's currently the most sensitive radio telescope of its kind. When astronomers pointed Meerkat at ORC1, the images were stunning. They revealed a complex internal structure, with delicate filaments and smaller arcs inside the main ring. This detail was crucial. It wasn't just a simple circle, it was a complex, structured object. Meerkat could also measure something called polarization, which tells us about magnetic fields. It found that the magnetic fields in ORC1 run along the edge of the ring, exactly what you'd expect if the ORC was created by a giant, expanding spherical shockwave. More recently, in late 2024, Meerkat discovered a new, significantly smaller ORC, suggesting they come in more sizes than we first thought, and that many more might be hiding just beyond our current detection limits. Other telescopes have joined the hunt too. The Giant Microwave Radio Telescope, or GMRT, in India, helped find the 4th ORC in archival data, the first one spotted in the Northern Hemisphere. And then there's LOFAR, a network of antennas across Europe that observes at very low radio frequencies. Using LOFAR data, a team of citizen scientists discovered the most distant and powerful ORC yet, over 7.5 billion light-years away. This one was even weirder. It had a double-ring structure, like a cosmic Venn diagram. Each new observation adds another piece to the puzzle. So, what are these things, physically? The edge-brightened ring shape strongly suggests we're not looking at a flat disk, but at the edge of a 3-dimensional spherical shell. Imagine looking at a soap bubble. The edges look brightest because you're looking through more of the soap film. It's the same idea here. And their scale is just staggering. They can be over 1 million light-years across. Our Milky Way galaxy is about 100,000 light-years in diameter. You could fit 10 Milky Ways side by side inside one of these giant ORCs. One of the biggest puzzles is why they are almost exclusively visible in radio waves. Deep searches with optical, infrared, and X-ray telescopes have found nothing. This tells us the glow isn't coming from hot gas like a nebula. Instead, the leading theory is that it's something called synchrotron radiation. This happens when extremely high-energy electrons are caught in magnetic fields and forced to spiral around them, releasing radio waves in the process. The magnetic field data from Meerkat strongly supports this idea. But like any good mystery, there's a twist. Recently, astronomers managed to detect X-rays from one ORC, nicknamed the Cloverleaf. They found a huge cloud of extremely hot gas, about 15 million degrees Celsius inside the radio circle. This hot gas is linked to the merger of about a dozen galaxies that are crashing together right in the center. This was a huge breakthrough, suggesting that at least some ORCs have a more complex story. As we find more, we're seeing there a diverse family. There are single rings, double rings, and big and small ones. Some have a clear central galaxy that seems to be the culprit, while others are cosmic orphans with no obvious parent. This diversity is a clue in itself. It probably means there isn't just one single explanation for all of them. This brings us to the cosmic whodunit. What could possibly create such enormous, ghostly structures? There are two main suspects. The current frontrunner is the galactic superwind theory. This idea, championed by a team led by Professor Alison Coyle, proposes that ORCs are the ancient ghosts of massive starbursts. A starburst happens when a galaxy, often after merging with another, starts forming stars at a furious rate, sometimes hundreds of times faster than the Milky Way. These new, massive stars live fast and die young, exploding as supernovae. If enough supernovae go off in a concentrated burst, their combined energy can drive a colossal wind of gas and cosmic rays out of the galaxy, moving at thousands of kilometers per second. This superwind then plows into the thin gas that exists between galaxies, creating a gigantic expanding shockwave. This shockwave energizes electrons, which then produce the synchrotron radio waves we see as an ORC. This theory has some strong evidence. Observations of the central galaxy inside ORC4 showed signs of a massive starburst that ended about 1 billion years ago. Computer simulations have also shown that a powerful galactic wind could indeed create a structure with the exact size and properties of an ORC. The model requires two things: a huge amount of material being blown out very quickly, and a very low-density environment for the shockwave to expand into. Since galaxies with both these properties are rare, it could explain why ORCs are so hard to find. The second major suspect is the merger of two supermassive black holes. Most big galaxies have a monster black hole at their center. When two galaxies collide, their central black holes eventually spiral into each other and merge. This is one of the most violent events in the universe, releasing a tremendous blast of energy. It's plausible that this cataclysm could also launch a spherical shockwave powerful enough to create an ORC. However, this model has some problems. For example, in some ORCs, the central galaxy isn't perfectly centered in the ring, which is tricky to explain if the event happened right at the galaxy's core. For the Cloverleaf ORC, the one with the X-ray gas, a hybrid theory is emerging. Perhaps an old blast from a supermassive black hole created a cloud of energetic particles, which lay dormant for eons. Then, a much later galaxy merger created new shockwaves that re-accelerated these old particles, causing them to light up and form the ORC we see today. It's a multi-stage crime scene. The existence of double-ringed ORCs adds another layer of complexity that none of the current models can easily explain. The truth is likely complicated, and different ORCs might be born from different cosmic events. So where do we go from here? The story of odd radio circles is just beginning. The first priority is simply to find more of them. A bigger sample will help us understand their diversity and test the competing theories. But the real game changer will be the Square Kilometre Array, or SKA. This next-generation radio telescope, currently being built in Australia and South Africa, will be a revolutionary tool. The SKA will be so sensitive it will likely be able to detect thousands of ORCs, many of them much fainter and more distant than the ones we know about today. With its incredible resolution, it will map their delicate internal structures in breathtaking detail, testing our models like never before. But ORCs aren't just a cosmic curiosity. They are a powerful new tool for understanding how galaxies live and die. If they are caused by galactic superwinds, then studying them gives us a direct view of one of the most important processes regulating galaxy growth. These winds are like a feedback mechanism, blowing out the gas needed for star formation and shaping the galaxy's ultimate fate. Do all massive galaxies go through an ORC phase? Is this how some galaxies transition from active star-forming spirals to quiet, red and dead ellipticals? These are the big questions ORCs might help us answer. From a serendipitous blip on a computer screen to a whole new class of celestial object, odd radio circles have reminded us that the universe is still full of surprises. They are a testament to the fact that every time we build a new tool to look at the sky in a new way, we find things we never expected. And as we continue to peer into the cosmic abyss, these giant, ghostly rings will surely have more secrets to share. Thanks for listening to G Fun Facts Online.